Hello, welcome to Physics Recipes. In the previous lectures, we have studied some basic concepts related to the motion of the object for the classical systems. So, in today's lecture, we'll be doing some numerical problems and then we'll move forward to Newtonian mechanics. Okay, so before starting the lecture, the thought of the day is whenever you are doing any task, do it consistently क्योंकि ऐसा कई बार होता है कि हमें फर्स्ट अटेम्प्ट सेकंड अटेम्प्ट में हमें सक्सेस नहीं मिलता है तो अगर हम उस चीज़ को छोड़ देंगे और कुछ नई चीज़ ट्राई करेंगे देन अगेन वील हैव टू स्टार्ट विथ ज़ीरो राइट सो डू नॉट लीव एनीथिंग विच इज़ नॉट गेटिंग सक्सीड और कई बार मीन्स 90% केसेस में लोग वहाँ ही जाकर छोड़ देते हैं जस्ट द नेक्स्ट मूव इज about to get success but they leave at the last stage. So whatever you are doing, just do it consistently with the 100% belief in yourself. Okay, all right, so let us start today's lecture. So here I will be discussing the question 1, which says an object of a mass m is thrown vertically up in the presence of a heavy air resistance. The time of ascent T1 is no longer equal to time of descent. Similarly, initial and final velocities are not equal. So show that this expression. Okay. So अभी तक हमने जो भी प्रीवियसली क्वेश्चन पढ़े या कंसेप्ट जो भी पढ़े उसमें हमने एयर रेजिस्टेंस को कंसिडर किया ही नहीं था. We will be assuming that there is no air resistance. So the question arises, what is air resistance? Okay. So what is air resistance? So air resistance is nothing but the force that air applies on the object which is moving through it. Okay. So जब भी कोई ऑब्जेक्ट एयर से पास हो रहा होता है तो एयर भी सम अमाउंट ऑफ फोर्स उस मूविंग ऑब्जेक्ट पे अप्लाई करती है जिसे कहते हैं एयर रेजिस्टेंस या फिर एयर ड्रैग भी कहते हैं. ओके, फोर्स बाय एयर एंड इट इज ऑलवेज एज द वर्ड सेज रेजिस्टेंस. एयर जो मोशन ऑब्जेक्ट परफॉर्म कर रहा है उसको रेजिस्ट करता है यानी रोकता है जिसके वजह से जो मॉलिक्यूल ऑब्जेक्ट की स्पीड है वो डिक्रीज होती है देन द एक्चुअल वन. ओके, ऑलराइट. सो हमें यहाँ कुछ बातें ध्यान रखनी है जैसे कि ये हमेशा अगर मान लीजिए कि मोशन मान लीजिए ये पार्टिकल है और ये डाउनवर्ड जा रहा है. ऑलराइट, तो इस पर कौन सा फोर्स ग्रेविटी लगेगा विच वी कॉल ऑल्सो एज वेट विच इज डिनोटेड बाय mg. Okay, and now here assume that here is air. So if the object is moving downward then air resistance acts upward. It is always directed opposite to motion of the object, right, of the object, the way I said in this example. Okay, some of the examples such as so because the air is resisting the motion of the object is losing some energy and momentum. All right, and it is falling down slowly. If there would have not been any resistance, then it would have fall fast. All right. So अगर हम इसका एग्जाम्पल देखें तो आई एम श्योर एवरीबडी हैज ट्रैवल्ड. Suppose you are sitting inside the train which is running, and if you take out, you can feel this drag or the force of air when, if you, जब आप अपना हाथ अगर खिड़की से बाहर निकालें, विच इज़ नॉट एट ऑल एडवाइजेबल, क्योंकि बहुत सारे एक्सीडेंट्स, बहुत सारी चीज़ें हो सकती है. इट इज़ नॉट एट ऑल एडवाइजेबल. ओके. सो अगर आप खिड़की से, बस जस्ट ट्राई टू इमेजिन और ट्राई टू अंडरस्टैंड द थिंग. ओके, अगर आप फास्ट रनिंग ट्रेन में बैठे हैं और अपना हाथ अगर बाहर निकालते हैं ट्रेन से या फिर विंडो से, तो आप एक फोर्स या फिर एक 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 फोर्स जो कि एयर आपके हाथ पर एग्जर्ट करेगा, और वो आप फील करेंगे कि वो जिस डायरेक्शन में ट्रेन जा रही है उसके अपोजिट डायरेक्शन में आपका हाथ, वो मतलब एयर उस पर आपके हाथ पर फोर्स अप्लाई करेगी. ओके, सो दैट यू कैन फील. बट रिमेंबर, इट इज़ नॉट एट ऑल एडवाइजेबल टू टेक आउट योर हैंड्स from the running trains. Okay, be careful. Okay, so as in the question says that the time of ascent, that means if the object is thrown up, so that the time, say the object is thrown from here to here, so the time that it takes to reach here, that will be ascent, and the time that it takes from here to here, that will be descent. So in this resistance thing, if the resistance is present, then you won't be, they won't be same. But if no air resistance, they will be same. Okay, and similar is the case with the initial and final velocities. All right, let's try to do this question. Okay, so what are the things we are given? F is the air resistance, m is the mass of the object, u and v are initial and final velocities respectively, and t1 and t2 are the uh, time of ascent and descent, and g is of course the gravitational constant. All right, so jab uh, okay, so let's try to write down the equation of motion for this. Okay, so during, let us consider the ascent case, that the object is moved upward. All right, so the air resistance and gravity. अब इनकी डायरेक्शन हमें फाइंड करना है. सी the let's say the object is thrown from here. Here is the object, this, it is moving upward, so gravity will be of course downward, and since the motion of the particle is upward, its air resistance will also be in downward, because I said here कि वो opposite to the direction of motion होगा. All right, so they both act downward. All right, तो अगर हमें इसके लिए इक्वेशन ऑफ मोशन लिखना है, लेट्स से, तो हम कैसे लिखेंगे? एम ए वन इज इक्वल टू माइनस एम जी and minus f, because they are, see, this is the acceleration, a1 is the acceleration for upward motion. Okay, so this is the net acceleration of the the acceleration of the particle will be in the up direction, so it is positive, and these both are in the downward direction, so we are taking the negative sign. Similarly, and if we find the value of a1, it can be written as, we take minus sign, f by m plus g. Fine. And similarly, during descent, air resistance, say the particle is coming down, so mg will be same, but the air resistance will be upward, and the net acceleration is downward. So let's say we are taking a2. So how can we write it? M a2, here we'll have minus sign, is equal to minus mg plus f, right? So if we find a2 from this equation, we'll get g minus f by m. All right. So let's now, if now this is the constant acceleration case, right? So because we the gravity is acting on this. Okay. So now if we write our three kinematical equation, let's start with, for ascent, we'll have, for ascent, say the particle is starting from this, it has initial velocity u, and let's say it has final velocity here v1. So for Sn, it will say it is the maximum height. So at that point, v1 will be 0, and we have initial velocity, right? So how do we write the kinematic equation? V is equal to u plus at. Fine. So here final velocity is 0. So 0 is equal to u plus, what is a? a1, and the time, let's say we are denoting in the question itself, it is given t1. Okay, so this is the equation. All right, now you have the value of a1 from this equation 1. So let's try to put it and find the value of u. U is equal to okay, let's put the value of u in this. So say 0 is equal to u, and the value of a is minus f by m plus g into t1. So let's say we are finding the time, because in this question we are asked to find the time. So what it will be? U upon g plus f by m, correct? So that will be our time. All right. We know another kinematic equation, which is v square is equal to u square plus 2as. So if we try to put the values in this equation, what do we get? v1 square is equal to u square plus 2a1 h. Let's say h is the height attained by the maximum height attained by the particle. Right now we do not know, so let us denote it by h. So let's put the values. U square plus 2 minus f by m plus g. Okay, that was the acceleration into h. So now if I want to find u from here, what do I get? 2h, here is a square, so we'll get square root of 2h f by m plus g. So this is the value of u. And if I put this value of u in this equation, so what do I get? T1 is equal to under root 2h and this square root and here the same term, so that will get cancelled. So I'll get under root g plus f by m. Okay, this is the value of t1 that I am getting. Now similar thing, remember what we have to find is the ratio. Okay, so for similar exercise we'll do for descent. That all the things we have done it for the particle going upward, and now for downward motion. So here final velocity is v, it is given by the question, and here the initial velocity, see, the particle was moving up, that was ascent. Okay, so here initial velocity was u, and here in this case final velocity when it was particle was reaching here, it was 0. But now when it is coming downward, now here it has attained the velocity 0. So for descent the initial velocity is 0, and here when it is reaching back to its original position, so it has the final velocity v. So for descent case, final velocity is v, initial one is 0 plus 2h, and here we'll put 8. Okay, so we can write 2h, and what is the value of a2? This one, g minus f by m. G minus f by m. Alright, and similarly if we use this equation for this, so what do we get? V is equal to under root 2h you can put and find it out, right? So g minus f by m. So that is the final velocity, and in order to find the time t2, it will be velocity upon a2. So this will be under root 2h. So this is the value of v actually, g minus f by m, and the value of a2 will be, we know it is g minus f by m. So here what do we get? 2h g minus f by m. Okay, so if we see this and this, what we have to find? T2 by T1. So let us compute T2 by T1. So if I see this, 2h under root 2h and 2h will get cancelled, and finally I'll get g plus f by m upon g minus f by m. Okay, it was the required thing. You can check from the question itself, and it was given itself. We have to prove it. Okay, so that was the thing. All right. So from this equation, what we are inferring, see here, what the T2 multiplied by this factor and T1 multiplied by this factor. Okay. So this equation tells us that T2 is greater than T1. Why? Because see, this is the less factor. Means if we put some values of these all the constants like g, f, and m, we'll get that the numerator has a greater value and the denominator has less value, and this less value is being multiplied with t2, which is equal to this factor multiplied by t1, right? Already there is a difference between this and this. In order to hold this equality, T2 should be greater than T1. And similar conclusion related to the velocities you can find is here. Let's write it here. So if you find the ratio of final velocities to initial velocity, you will get square root of g minus f by m upon g plus f by m. And similarly, the conclusion you can draw it from v, the final velocity is less than the initial one. Okay, so that was the solution to this question. All right, so let us move to the Newtonian mechanics, is which is governed by three laws which are given by Newton. These are basic laws for the classical systems that describe the motion of the object, and it relates the motion of the object with the forces acting on that moving object. Okay, so let's I'm sure you are familiar with all the three laws, so I'm just summarizing it for you. Okay, so first law is a body remains in a state of motion, in a state of uniform motion, or rest unless this is for a straight line. Okay, that I forgot to write. Rest unless it is acted upon by, unless acted upon by some external force. All right, so it says that if any body is kept at the rest, it will be always in the rest state, and if it is performing the uniform motion with a constant speed along a straight line, it will be always stayed there. Okay, so the second law says that when a body, when a force is exerted on a body is equal to time rate change of change of its momentum. Okay, so it basically gives us the equation of motion, which is given by this, right? P is the momentum, F is the force. And this is the derivative, all right? So we use this to solve the classical systems. And the third one is, to every action there is equal and opposite reaction. Just I'm stating these because I'm sure everybody who's studying physics, these three laws are well known. Okay, all right. So whenever we'll have some problems related to Newton's equation or classical systems, we try to address them. So let us try to um, means look how do we approach those problems. Okay, so we use Newton's laws to address these questions. So let us do step by step. So always first step is to resolve all the forces, in the direction of motion, in the direction of motion. And one thing that we need to keep in mind, that we apply here, the Newton's laws we apply, the equation of motion that I just wrote above, that we always apply when there is change in the acceleration of the particle during its motion. If it is constant, we go back to kinematic equations. All right, this is the difference that you must keep in your mind while approaching the questions. All right, okay. So in the direction of motion and perpendicular direction, along perpendicular direction of motion. We'll see how to use these approaches, everything we'll see. So just be little patient. Write equation of motion in the direction of motion. In the direction of, and how do we write in the above itself? Just before this we saw the equation of motion. Okay, because it is equal to dp by dt. Okay, here we assume we keep mass as constant. We'll further see how to deal with the variable mass problems, but for now let's assume that the mass of the particle will remain the same. Okay, and one all right. So this acceleration, this we generally use to solve, and this acceleration can be written as dv by dt, where v is the velocity. I should keep here the vector quantities. Okay, in the above also. Okay, one another way is such that x is the displacement, and also you can write it like this: v dv by dx. Okay, so we also can use in some of the problems this thing also. Okay, so we'll see how to do it, how to approach the problems, how to solve them. Okay, and also remember, if the acceleration is constant, we'll go back to kinematic equations. Fine. Okay, since if we put these values of acceleration in this equation, and there may be some another force terms, it may not be the single component, so we'll get the differential equation. Okay, we'll get differential equation. Okay, it may be in some of the questions आपको सिर्फ velocity find करनी होगी for the moving object. In some of them you'll have to find a displacement, and there will be, depending on the question, आपके पास जो differential equation भी होगा वो भी different होगा. It may be first order or it may be a second order differential equation. Okay, so we may have two types. If we have first order differential equation DE, here we can go for variable separation. If the question is about two variables, we can separate them because it is a first order differential equation. Or if it has some type, the variable is also present, or some mixed kind of thing. So let's say we have dy by dx plus p of x into y is equal to q of x. If this kind of problem we'll have, you can directly approach to the solution like this: y e to the power I is equal to integral e to the power I q dx plus c. This c is constant, and e is the exponential, I is equal to integral p dx. Okay, and this p and q are functions of x, and you can find this value using this. Okay, I will not be going into the mathematical things, but we may need some of the mathematical background. So if it is a second order differential equation, so see, if we are asked to find the displacement of the moving particle, then we'll go to the second order differential equation. So the thing that I'm discussing here, the differential equation which has constant coefficients. Okay, so the type of the equation that I will be discussing is a2 d square y by dx square. This y and x can be something like in the above thing. Did not be confused with here the displacement, and this is not acceleration at all. Okay, these are some constant values So here in the above problem, you can replace the y by x and x by t. Okay, it is just a representation of the differential equation dy by dx plus a naught is equal to, here also we can have some x dependent term, we may have some constant, or it may be zero, anything that can be. Okay, so note here, a a naught, a1 and a2 are constants. Fine. Okay, so the solution of such an differential equation, it is given by yc plus y. So yc is called as complementary solution and yp is particular solution. I'll come how to deal with the, and even I'll be discussing some of the questions. So need not worry if you're not getting anything here. Just you may go through, go with the flow, and then again come back, you will get the things. So okay, so here few cases I'll discuss. Say case 1, depending on f of x, the particular solution will be different, and the complementary solution is quite easy. So let me discuss first the complementary solution. Okay, so let me discuss first complementary solution. So what you have to do it, you just remove this 8, means divide this whole equation by a2 and convert some another constants, and achieve the form of the differential equation such that d square plus, here it will be a1 by a2, some another constant you can replace, d plus a naught by a2 equal to 0. You need not take, when you are finding the complementary solution, you need not take this f of x, okay? The right hand side will be simply 0. And consider, after solving this equation, you get two roots. Fine. Say you are getting r1 and r2 as two roots of your differential equation. So your complementary solution will be, see here, it is a second order, so we'll get two roots. Okay. So depending on whether your r1 is equal to r2 or not equal to r2, the complementaries, let us consider the first case in which they both are not equal. So just what you have to do is c1 e to the power r1, and it is with respect to x, so you'll write x plus c2 e to the power r2 x. Okay, and if it is both are equal, then आपका complementary solution हो जाएगा c1 e to the power r1x plus c2, बट आपको यहाँ पर x से मल्टीप्लाई करना पड़ेगा, x e to the power r2x. और अगर ऐसा और भी मान लीजिए कि थर्ड ऑर्डर डिफरेंशियल इक्वेशन होता, तो हम और एक एक्स स्क्वायर से भी मल्टीप्लाई करते हैं आने वाली आगे की टर्म्स को. ओके, सो दैट इज द टेक्निक. फाइन. सो दिस इज द वे यू फाइंड द कॉम्प्लीमेंट्री सॉल्यूशन. All right, I don't have a place here for particular solution to discuss. Okay, so but something I'll discuss because it's important. So for पर्टिकुलर सॉल्यूशन में आपको क्या करना होता है? Assume that case 1, f of x is of the type e to the power ax. Okay, a is again constant and x is your variable. So how do you find the particular solution? Yp is equal to 1 over f of d. Okay, f of d you will write multiplied by f of x. F of d will be whatever you will have as a function, so you will write there. So in this case, um, if you have, say here, there will be some d square, right, such that term. So whenever f of x is equal to exponential ax, so you will have to replace, means put d is equal to a. Fine. And remember one thing, by putting in this expression, if you're putting the d equal to a and this denominator becomes 0, if f of d is equal to 0, which is not acceptable solution. So here we say case failed. So how to go ahead? Just you need to do yp multiply by the variable which is x and f dash, take the derivative with respect to d in the denominator itself and go ahead as usual, means as the way you were going before. Okay, and now the another case that I wanted to discuss was case 2. If f of x is equal to sine or say cos, both the cases will go same. So what you have to do, this will be common. So in that case, this f of d means that this denominator thing, you have to do it, means whatever there is, you do. इस इक्वेशन f of d में जो भी इसको ऐसे कन्वर्ट करें, सम अनदर फंक्शन phi of d square. That means you will have d square, d power 4, like that terms. Okay, here we may not get d power 4, but usually you have to convert this in a d square form. So if you have sine or cos ax, so what you have to do is d square is equal to minus a square. इस इक्वेशन में आप पुट करेंगे and then solve. I'll tell you in the examples how we can go about it. Okay. All right, let's try to do some questions related to this, and this concepts will be repeated. So if you don't understand, so need not worry about that. All right. Okay. So let's try to do the question. About the question says a ball of mass dropped from a building with the initial velocity. In addition to gravity, the ball experiences a damping force. Gamma is the constant velocity and v is the instantaneous velocity. Okay, and we are given these parameters and we have to find the distance traveled by the ball in the time t. So let's try how do we do. Damping force means um damping is again a drag force. You can call it as drag force or means the another example means the words can be such that if it is the motion is taken along in the fluid, so their viscosity, right, in liquids, so such are the drag forces. So again, damping is the drag force. So let us try to do it. Let us write equation of motion m dv by dt as per the Newton's equation. We'll have gravity. See, the ball is dropped. Okay, so gravity is mg acting downward, and the net acceleration of the particle is also downward. Okay, so and this damping force is a drag force, or the resistance, it will be upward. Okay, so here we are taking the reverse conventions. So we'll write this gamma b. Okay, means just you see here, means if I don't confuse, यहाँ पे कंफ्यूज नहीं होना है आपको कि mg को माइनस क्यों नहीं लिया जा रहा है. ओके, so because see, the net acceleration is downward, mg is also downward, and this gamma v is opposite to that. That is the meaning of the this equation of motion. So need not confuse. You can also do like this, like take this minus minus, and this will be plus. So the what to say, the physics, whatever the physics is, that is not going to change. It is the sign convention, okay, that we are following. It is as simple as that, because in the question it is given, so we are taking the conventions like that. Okay, now here we, what we can do if we solve this, because see, we have to find the distance. Okay, so you can raise the question like यहाँ पे dv by dt नहीं लिखते, अब dx square by dt square लिख लीजिए, क्योंकि हमें x फाइंड करना है. Okay, but that will not be the solution, because here we are having the term v. Okay, so in order to replace, we know that we have to find the distance, but this won't serve the purpose. Okay, so let us try to do this first order differential equation. So we do variable separation, we do dv, और means वेरिएबल सेपरेशन में क्या होता है कि जैसे dv है यहाँ पर, तो यहाँ पूरे इक्वेशन में जितना भी dv होगा वो सारा एक ही मतलब एक ही LHS और राइट हैंड साइड में आप लेकर जा सकते हैं. तो अगर मैं m से डिवाइड कर दूं तो ये g माइनस गामा बाय m into v, okay, which is equal to dt. Now let's integrate this dv upon g minus gamma by v. So the limits will be 0 to v, because the ball is dropped from certain height. So when the ball is dropped from certain height, its initial velocity is considered as 0. Okay, and here it will be 0 to t. So let's denote it by t. Now, if you see this, we have to integrate it, right? So I have here v, डिनोमिनेटर में मेरे पास v है, बट अगर somehow मैं इसका डेरिवेटिव ऊपर लेकर आ जाऊं तो I can write it as log of v, right? If you remember, 1 by x dx is nothing but log x. Okay, so if I see here, there is a constant term, right? So let me do multiply, and here in the integration 0 to v minus gamma by m dv upon g minus gamma by m v. Now this v has some derivative, its derivative thing here in the numerator, so I can write this as log of denominator. Okay, so this will be m by gamma log of g minus gamma by m into v is equal to t. Okay, so from this equation, if I do some rearrangements, I can find, this is easy, you also can find, I'll get m g by gamma into 1 minus e to the power minus gamma t by m. जस्ट आपको लॉग की प्रॉपर्टी यूज करनी है एंड v आपको फाइंड करना है. ओके, so now we are given some values, right? This mass, gamma and g all are 10. So if we put them, we'll get v is equal to 10 into 1 minus t. Okay, and now you replace this v by dx by dt is equal to 10 1 minus e to the power minus t. Okay, now again you'll have here, what do you have? A first order differential equation. Okay, and remember this question has been asked in the net, CSIR net, in the December cycle. Okay, so what do? अगेन डू वेरिएबल सेपरेशन. वी डू, हमारे पास x के लिए कोई भी टर्म नहीं है, सो x 10 इंटू 1 माइनस ई टू द पावर माइनस टी डी टी. ठीक है, तो आप यहाँ से इसकी लिमिट्स क्या ले लेंगे आप, 0 टू t और यहाँ की 0 टू x. सो x इज इक्वल टू 10 और इसका इंटीग्रेशन आप कैसे लेंगे, 1 का इंटीग्रेशन t और e टू द पावर माइनस टी का माइनस टी अपॉन माइनस 1. फाइन, एंड लिमिट्स आप क्या लगा देंगे यहाँ, 0 टू t. तो अगर आप सॉल्व कर लेंगे इसे तो 10 यहाँ t प्लस e टू द पावर माइनस टी और माइनस 0 और माइनस e to the power minus 0. So you will get 10 t plus e to the power minus t minus 1. E to the power 0 minus 1 होता है. Okay, so that is the distance traveled by the particle. And same question आप other way भी find कर सकते हैं using the differential equation. Okay, so that you have to try. I'll be writing just the conceptually, I'm telling you how to do it. Okay, so you know from this equation, if you write all the values, so what do you get here, just say a is equal to 10 minus v. Okay, देखो यहाँ पर dv by dt is a और आप m से डिवाइड कर दो और g गामा की वैल्यूज पुट कर दो तो आपको ये वाला इक्वेशन मिल जाएगा. तो आप फिर क्या कर, इसको डायरेक्टली dx स्क्वायर बाई dt स्क्वायर इज इक्वल टू 10 माइनस dx बाई dt, ऐसे आप इसको सॉल्व कर सकते हैं. ओके, तो ये सेकेंड ऑर्डर डिफरेंशियल इक्वेशन बन गया। तो आपको ये वाला अप्रोच यूज करना है। ओके, कॉम्प्लीमेंट्री सॉल्यूशन एंड पर्टिकुलर सॉल्यूशन, दैट इज द practice for you, that I'm not going to do. Okay, so let's do this another question that is asked in June 19 in CSIR net examination. So the question is, the equation of motion of a forced simple harmonic oscillator is given by this. A is the constant, and at resonance the omega is the frequency reaches this value omega. Okay, so we are asked the amplitude of the oscillation is, and these are the four options. Okay, so we are given, हमें क्या दिया है, डिफरेंशियल इक्वेशन दिया है। ये डॉट का मतलब क्या है, डेरिवेटिव विथ रिस्पेक्ट टू टाइम। ओके, तो अगर हम इसे यूजुअल नोटेशंस में लिख लें तो क्या हो जाएगा, प्लस ओमेगा स्क्वायर एक्स इज इक्वल टू ए कॉस ओमेगा टी। ओके, अब मैंने जैसे यहाँ पे आपको बताया कि इस क्वेश्चन को अप्रोच कैसे करते हैं हम, यूजिंग दी, ये सेकेंड ऑर्डर डिफरेंशियल इक्वेशन है विथ कांस्टेंट कोएफिशिएंट्स, तो हम कॉम्प्लीमेंट्री और पर्टिकुलर सॉल्यूशन फाइंड करेंगे। तो कॉम्प्लीमेंट्री सॉल्यूशन इज वेरी इजी, 2d स्क्वायर प्लस ओमेगा स्क्वायर x इक्वल टू 0, दैट मीन्स x 0 नहीं होगा, ये टर्म 0 हो जाएगी, is equal to 0. So d is equal to plus minus I ओमेगा, बिकॉज जब आप राइट हैंड साइड में ओमेगा लेकर जाएंगे तो वो माइनस ओमेगा स्क्वायर हो जाएगा, और जब हम ऐसी माइनस क्वांटिटीज का स्क्वायर लेते हैं तो प्लस माइनस आई आता है, आई इज द कॉम्प्लेक्स थिंग। ओके, तो इसके लिए हम पर्टिकुलर कॉम्प्लीमेंट्री सॉल्यूशन कैसे लिखेंगे, C1 cos ओमेगा टी प्लस C2 साइन ओमेगा। जब रूट्स कॉम्प्लेक्स होते हैं, अगर यहाँ पर रियल पार्ट होता तो फिर वो एक्सपोनेंशियल के पावर में हम लिख लेते, इंक्लूडिंग द वेरिएबल। यहाँ पे हमारा वेरिएबल t है। ओके, so this is the, you have to little bit see the mathematical concept related to differential equations. Okay, okay, so for particular solution के लिए कैसे करेंगे, x इज इक्वल टू 1 अपॉन, ये डिफरेंशियल इक्वेशन हम यहाँ लिख देंगे डी स्क्वायर प्लस ओमेगा स्क्वायर, और हमें यहाँ क्या दिया है, a cos ओमेगा t। Okay, so see here, we are given that at resonance, okay, when w is equal to this, that means interchangeably I can write omega is equal to w. Fine. Now here we have to put d square is equal to minus ओमेगा स्क्वायर, बट ओमेगा इज इक्वल टू, क्योंकि हमें एम्पलीट्यूड वहीं पे पूछा है, देखिए at resonance when this equal to this, the amplitude of the oscillation. Okay, so we can write it like this, minus omega square. Now if you put in the above one, we'll get the denominator to be 0, which is not our case actually. This is not acceptable, so here case failed, this case failed. So for next time, what you do is you multiply with the variable, here t is the variable, t upon You take the derivative of this term, which is 2d into a cos omega t. Okay. Similarly, you can write a t cos omega t and 2d. Okay. So now what do we have to do? X is equal to a t by 2 1 by d cos omega t. Now see, d is, in our case, what is d? If you see correctly, it is dx by dt. Oh, d by dt, sorry. Yeah. D is d by dt. So 1 by d is, can be taken as, 1 by d can be taken as the integration with respect to d, with respect to dt, time. So if we do here at, because differentiation and integration are reverse to each other, up, okay, reciprocal of each other. So if you integrate cos, so what do you get? Sine omega t upon omega. And now if you write the complete solution, oh my god, sorry, x is equal to, what was the complementary solution? C1 cos omega t, plus C2 sin omega t, plus particular solution at by 2 omega sin omega t. And see, at the resonance, okay, at the resonance we have asked what is happening. So first option is saturates at the finite value, increases linearly with time, increases with the time as under root t, or increases exponentially with the time. Means we have to find here, had to find the x as a function of t and how is it varying. Okay. So if you see here, if the resonance happens at the large time, that is t is large, so at high, at large time values, if you see this, sine and cos will fluctuate. These are oscillatory terms. It will go plus and minus. Okay. So only they will oscillate between plus 1 and minus, means depending upon the amplitude. So if you see the main dependence at the large time values, the dominating term will be at sine omega t upon 2 omega. The moment you will increase the time, this term is going to dominate. So what will be the correct option? This one, increases linearly with time. All right. So that was the question from CSIR net. It was easy, not at all tough. Easy, बिल्कुल easy था question. Just हमें कुछ concepts ध्यान होने चाहिए. क्वेश्चन देखकर ऐसा लगता है कि पता नहीं क्या ही पूछ लिया है, बट इफ यू आर गोइंग टू सॉल्व इट, इट इज just the practice. Okay, so that's all for today's class. I'll end here with a tip टिप ऑफ द डे। सो जब भी आप एग्जाम्स में क्वेश्चन अटेम्प्ट करते हैं ना, तो कई बार क्या होता है कि हम कहीं स्टक हो जाते हैं। कोई क्वेश्चन हमें आता होता है, कंसेप्चुअली भी हमें पता होता है, मैथमेटिकली भी हम स्ट्रांग होते हैं, हमारी प्रैक्टिस अच्छी होती है, पर कभी कभार बीच में कुछ छोटा सा डाउट आ जाता है जिसकी वजह से हम स्टक हो जाते हैं कि ये करें या करना है या नहीं करना है। तो अगर ऐसे किसी क्वेश्चन में आप फंस जाते हैं ड्यूरिंग द एग्जाम्स, सो सो ट्राई टू डू दैट confusion, try to resolve that confusion at the end। क्योंकि कई बार क्या होता है जब हम स्टक हो जाते हैं, क्योंकि हम कॉन्फिडेंट होते हैं कि हमें तो ये आता है, हमने अभी पढ़ा है, पर होता क्या है उसमें हमारा बहुत सारा टाइम उसमें वेस्ट हो जाता है और हमें रियलाइज़ नहीं होता उस समय, क्योंकि हमारे दिमाग पर काफ़ी सारा प्रेशर होता है कि हमें क्रैक करना है, हमने तो ये पढ़ा है वो पढ़ा है। सो द टिप इज always during the exams, just focus on the question which are easy and target them first। and when you save your time, जब आपके पास टाइम बचता है, तब थोड़े टफ क्वेश्चंस पे या फिर जहाँ आप स्टक हो चुके हैं उन क्वेश्चंस को अटेम्प्ट करें। अगर आप कहीं स्टक हो रहे हैं तो जस्ट गो गो अहेड एंड देन आफ्टर सम टाइम come back to the question। okay, so you will not, there is two advantages of this thing। फर्स्ट, आपका टाइम सेव हो जाएगा, और सेकंड, आपका कॉन्फिडेंस लूज नहीं होगा। ओके, सो ऑलराइट, सो दैट इज ऑल फॉर टुडे।